Great. So welcome to equations involving number bases. Okay. And next time we are going to um, find the unknowns when an equation is given. Okay. Which involves bases or number bases. All right. Good. So whenever you are dealing with equations like this, for instance, the four examples before us now, when you are asked to find the unknown values or solve for the values of letters, everything you are going to do, you are going to solve it in base 10 numeral, okay, or in decimal numeral. That means you are going to change everything to base 10. That's how you are going to solve it to be able to find those values. Okay, so always when you are asked to solve questions like this, you need to solve it like you are changing to base 10. Okay, so we waste no time. Let's take one first example. Okay, great. So for example one, we have 4 2 base n is equal to 1 2 base 10. So the base here, we know that this is in base 10 and we are to find what n. This is what we're looking at. So it means this question we are looking at which base. Okay, good. And you know how to change everything in base 10. So what you do is 4 multiplying what the base. So we do this one, this part, and then we do the other part. Okay, multiplying what the base, which is base n. Okay, so it is the same thing we did previously. That's what we are doing. So that if here, in case you were given base 5, you multiply by 5. So here, once you are given base n, so you are multiplying by base n, which we don't know the base, plus 2 multiplying the same base n, which is equal to, now remember I told you that whenever you are giving values, so this one you should know this so that you don't waste time doing this as well. Whenever a number is given in base 10, know that it will still give you the value there. So it means 1 2 base 10 will still give us what, 12. If you want to do it in this form, you will still get the 12. So you don't worry yourself and write all this again. You only write what, the 12. So as we are doing, whenever you see a value in base 10, it should give you the same value. That's why I'm writing the 12. Okay, all right, that's great. So 4 times n gives us, now we need to distribute the exponent. So this is 0 and this is 1. So we know that 4 times, what's n exponent? 1 is n. Okay, plus 2 times, what is n exponent? 0. Now remember I've told you that any non-zero number exponent 0 is 1. So no matter what, whether it is a letter, it is a number, provided what is here is not 0. Okay, if it is not 0, then the answer is definitely going to be 1. But if it is 0, then you are going to get undefined. That's why we are saying that any non-zero. We didn't say any number, because 0 is also a number. So if you see 0 exponent 0, it means you are going to get undefined. But any non-zero number, provided once you realize that that number, whatever is here, is not 0, okay, it's any number other than 0, then you are going to get 1. So take note of that. Okay, so it's not only numbers or values that can give you 1, whether letters or whatever. Okay, great, which is equal to 12. Now 4 times n gives me 4n, plus 2 times 1 gives me what, 2, which is equal to that. Okay, yes, that's very simple. So we don't have to waste time on this. Okay, so let's group like terms, which is equal to 12 minus 2, and then we have 4 and is equal to 10. So we are going to divide both sides by 4. So n gives us what? So we know that this is 10, this is 4. 2 divides 4 how many times? 2 divides this how many times? 5. So we are going to get 5 on 2. And that's going to be our answer. Or you can also write the decimal part, and that is going to be what? 2.5. Great. So that is how equations like this, that's how we answer it. Okay, now let's tackle the second example. So equations follow this principle, and it's very, very easy. So for example 2, we follow the same principle. So we are still going to write 1 multiplying what base? Y, plus 1 multiplying 4. So 4 rather, multiplying y, plus 2 multiplying y. Okay, great. Which should give us, and this one we are giving base, so we do for the right side as well. So 1 multiplying which base? 4, plus the same 1 multiplying 4, plus 3 multiplying what? 4. Good. So here I will start writing my 0, 1, 2, and the right side to 0 here, 1 here, and then 2 here. Okay, great. So we know that this is 1 multiplying what is y squared? Y is still squared, plus what is 4 times what? Y exponent, not y, so it's still y, plus 2 times what is y exponent? 0, and it is 1, which is equal to what is 4 exponent 2? That is 16, plus what is 4 exponent? So this is 4 exponent 2, this is 4 exponent 1, so we have 1 times 4, plus 3 times what? 4 exponent 0 is what? 1. Good. 1 times this gives us y squared, plus 4 times y gives us 4y, plus this, which is equal to 16, plus 4, plus 3. So we can group items. Now we have y squared plus 4y plus 2. So if I add all this, I'm going to get what? 23. So minus 23, which is equal to 0. Now I have y squared plus 4y minus 21, which is equal to 0. Now what equation is this? This is what? Quadratic equation. Okay, so once we get quadratic equation, then we solve this quadratic equation by factorization method. We are going to use factorization method to solve this. Okay, previously know that when we're doing the equation, okay, equation word problem on linear equation, we solve similar examples where we use what? Factorization method. So this time I'm not going to waste time on that. Let's use the factorization method. So 2 factors, if you multiply the coefficient of this by that, you are going to get what? So this is the coefficient of this is what? 1, and the constant is negative 21. So if we multiply 1 by negative 21, we are going to get what? We are going to get negative 21. So the negative 21, we are going to find 2 factors, and those 2 factors, if we find the product of those 2 factors, we must get negative 21. If we find the sum of those 2 factors, we are going to get what? 4y. That's what we are talking about. So what are those 2 factors of the 21? Remember, listen again. I said in using the factorization method, as I said, we've done this previously in our previous lesson, but let me still remind you. If you are using factorization method, what do you do? What you do is find the value, the coefficient of the value or the letter with exponent 2. Find the coefficient. So the coefficient of this y squared is 1. After getting the 1, you multiply the 1 by whatever constant you have here. This is constant. So the constant we have here is negative 21. And we have coefficient of y squared as 1. So 1 times negative 21 gives us what? Negative 21. Negative 21. And I'm saying that the negative 21 you are going to find two factors of this negative 21. Those two factors, we can find both negative and positive factors of 21. Those two factors, if you find their product, the answer you get should be the same as the negative 21. And when you find their sum, their sum should be equal to what? The 4 you see here. Have you gotten that? So what are those two factors of this negative 21 that in which its product gives negative 21 and its sum gives what? 4. So you can think of what? I think we can talk about positive 7 and negative what? 3, because if you multiply 7 by negative 3, you are going to get what? Negative 21. And if you add them, to, you are going to get positive 4. So you realize that the positive 4 is here and the negative 21 is also here. So it satisfies. So because of that, then we are going to replace the 7 plus the y with what? 4. We are going to replace this by what? The 4y. So in this case, I will write my y squared plus then 7, because this is positive, so 7. Then I'll add the y. Then we have here minus 3. Okay, minus 3. So the 3 to, I have to add y, so that if I simplify this, it will give me the positive 4y. Then I will add my 21, which is equal to 0. Okay, all right, great. So once we have this, then we can put this y squared minus or plus 7y in one bracket, plus, and then we put negative 3y minus 21 also in one bracket. Then we do the factorization. So here is where we are going to use the factorization. So here we factor y out, and we have y plus 7. Here we factor what? Negative 3 out. Then we have here y plus 7, because negative 3 times y gives me this, negative 3 times 7 gives me this, and the same applies here. When you multiply, you get that. Okay, so that is what we have now. Okay, all right. So once you have y out, negative 3, so we put those outside the bracket in one bracket, and then because this and that are the same, then we pick one of them and equate to 0. Good. So we pick this, equate to 0, pick this, equate to 0, and solve. So we have y minus 3 is equal to 0, or y plus 7 is equal to 0. Now I can say that y is equal to 3, or y is equal to what? Negative 7. So these are the two solutions or two roots we have for the equation. It means that the value of y, or the values of y, are what? 3 and negative 7. But remember, because we are dealing with number base, this negative figure will not work. It doesn't satisfy. So we are picking what? The positive value, only the positive value. So we will not accept this one. So therefore we can conclude that therefore the value of y is 3, and that's what we are using. Okay, so when you work out and you get answers like this, reject the negative answer and accept what? The positive answer. Okay, all right, because when you substitute these two values, it is only the 3 that is going to what? Satisfy the equation. Okay, all right, now let's take our third example. So for this one, for example, 3, we have 4p 5 base 8 is equal to 293. Okay, so this one too, we are going to do that. And you know that once there is no base here, know that it is in base 10. And as I said, whenever it is in base 10, it still gives you what? The same value. So this one, you don't need to touch it. You need to keep it as it is. So I can start with 4 multiplying my base, which is 8, plus, and then the next letter, the next figure here is my p multiplying the base, which is 8, plus 5 multiplying the base, which is equal to 293. So I will start with 0, 1, 2. Now we know that 4 multiplying a squared is what? 64, plus p multiplying 8, plus 5 multiplying 1 is equal to 293. So what is 4 times 64? And that gives us what? 256, plus p times 8 gives us 8p, plus 5, which is equal to 293. So I can group like terms, and then I'll have 8p is equal to 293 minus 261. 8p is equal to 32. Let me divide both sides by 8. And p gives me what? 4. Good. So it means that my value of p is what? 4. If we substitute 4 here and work out, you must get this answer. That is what it means. Okay, so anytime you work out, you need to substitute your value here and test whether your answer is right or not. If you are not right, then it means that there is no solution. If you substitute this value here and the answer you get, this part is not the same as this part, then you know that there is no solution. Okay, yes, but here if you test it, you realize that you get the same answer. Now let's look at our last example, which is example 4. So for example 4, we have 1, 2, 3 base 5 minus 4, 2 base x is equal to 12. So we are going to do it the same way we solved the previous example. So this one, following the same base 10, we are going to write 1 times what? 5 plus 2 times 5 plus 3 times 5 minus, so we have this. Now when you are doing that, you need to bring this minus and do it this way. So we have 4 times what? X plus 2 times x, which is equal to 12. You see how I wrote it? Most students, when you are doing that, they bring the minus here against only this. Okay, know that the negative is affecting everything here. Okay, so let me start with my 0 here, 1, 2, and here too we have what? 0 here and 1. Okay, because this one is different from this one, so you do for each of them. Okay, now we know that 5 squared gives me what? 25, and then 2 times 5 plus 5 exponent 0 gives me what? 1 minus, so we have 4 times x exponent 1 gives me what? X, plus x exponent 0 gives me what? 1 minus is equal to what? 12. So this is 25 rather, not 2. Okay, So 1 times 25 gives me 25, plus this times that gives me what? 10 plus 3 minus 4x plus 2, which is equal to 12. Now, since we have this one, we need to open the bracket. So let's add this plus that. It gives me what? 38 minus this times this gives me 4x minus what? 2, which is equal to 12. Yes, so if I'm grouping like terms, then I can say negative 4x is equal to 12 minus 36. So I have 4x is equal to, if I subtract it, then I'm going to get what? 20 or negative 24. Now I can divide with by negative 4. So this one will go. Therefore, I have my x to be what? 6. Good. So it means that the value of x in such example is given as what? 6. So these are some examples of equations involving number bases. There are a lot of examples that you can think of. Okay, so my dear students, I will entreat each and everyone to solve more examples. Okay, so we shall end here and continue next time. Now, in our next video, we are going to look at how we can fill in tables. Okay, tables of involving number bases. Okay, tables of number bases. That's what we are going to look at in our next video. So see you in our next video. Bye bye.